the ground level power supply, which is a third rail embedded into the track. So you have an example of Bordeaux in France, where we implemented that the first time. It was in 7 years ago, put in service 7 years ago. We are currently developing the same in Dubai, which will be fully all along the line with the system. So how does it work? In fact, we segmented the street level. So you see the rail in the middle. So this rail in the middle is the way to give the power supply to the train. So you have the rail here, and this one is the power supply one. So it's completely embedded in the track. The conductive segments are only when the tramway is going on. So which means when there is no train on top, you can walk on it, there is no issue, no voltage at all. So this is really safe because it's only energized under the train and there is no power at all outside. So how does it work? We have antennas in the middle of the train, under frame of the train, and we have, so this is the embedded power supply in which it is fed underground, and only one segment is energized. So as soon as the train has a two antenna on one segment, the red segment is energized, which means the rest there is no current. And of course, behind the train and in front of the train, there is no power as well. So you can see some picture of, it's mainly Bordeaux in France, southwest of France, when you see how the tram is integrated in the historical city, on the bridge, on the greener area. So globally, it really facilitates road crossing and emergency access because there is no infrastructure around. Facilitate maintenance of the city equipment and offer a total safety to the pedestrian. So that is the first solution for the power supply of the train. The second solution is onboard energy system storage. One example where it is implemented is the tramway in Nice, in the south of France. So this is really an onboard solution which allows the tram to operate, but only on a short distance, without the catenary. So in fact, there is two solutions to implement that. Either using battery, so we can store large quantity of energy, but we have quite low power to the mass of the train. And we have another technology which is a supercapacitor, where we have high power, and both solutions are limited on a small length, maximum 1 kilometer. Of course, those two solutions can be complementary to either APS or the catenary. So we can do a mix depending on the configuration of the line, depending on the city, depending on where we want to implement it. So today the battery is in service, battery solution is in service since 2007, and supercapacitor is implemented in Paris since last year. So supercapacitor is really a recent technology that everybody is trying to develop on many applications. So we have this as well in Rotterdam. So you see here one area where we have the catenary, but on some area where there is especially road crossing, so you don't see at all this infrastructure. It can run with using the battery. Then I will give you some information as well on the design of the tramway, how a modern tramway can really be integrated in the city. So now we have really creative design, including the outside of the train. So each city, so we can personalize the train inside, outside, and especially the front end of the train is really different for each city. We can personalize according to the image the city wants to give. Can be through participation of the citizens to choose the design of the train. The same on the interior. We can have really creative interior design, allowing, of course, access for everybody, especially disabled people. So all the trams are completely low floor with information, so then it can be customized in terms of passenger information, video, everything can be done inside the train. You see some other design view. Brightness is quite important as well. Electrical lighting is really friendly for the passenger. In terms of seats, you can see that maybe it's really common, but it's very important the design of the seats, and you can participate to the well-being and to the impression given to the passenger. Of course, all access to disabled, even storage or bicycle, everything can be integrated. So, modern tramway, is it adequate for Hong Kong? I think in the past presentation just before, we were talking about city planning, complementary between different systems. So, especially so road, metro, and it can be very complementary to the metro system. There is a metro system quite well developed, maybe not enough, but development ongoing in Hong Kong. Tramway can be an alternative as a complement to really go on some area where there is less people transportation need, but can replace the road traffic and can reduce the road traffic.
Before you change that, imagine that on DeVoe Road. Or Nathan Road, yes, imagine that on DeVoe Road.
I think it was said as well previously that nice environment, complementary with other type of transport. So tramway is really something that is easy to integrate, but can really change the way the city can be organized. We are talking about reclamation area earlier on. I think it's typically something that you can have a pedestrian area with a tramway along to bring people along with no cars at all, or even no bus on this particular area. That's it for me.